Natural language processing speech to text. Natural language processing speech to text is a profound application of deep learning which allows the machines to understand human language and read it with a motive to act and react as usual humans do. The basic idea behind NLP is to feed the human language as in the form of data for the intelligence system to consider and then utilize in various domains. NLP is usually deployed for two of the primary tasks, namely speech recognition and language translation. We have already studied the language translation in the previous lessons. Let us look at the speech recognition. Going a little deeper and taking one thing at a time in our impression, NLP primarily acts as a mean for a very important aspect called speech recognition, in which the system analyzes the data in the form of words either written or spoken, helping us out with the text to speech and speech to text systems. For our view, we will focus on speech to text, which will allow us to use audio as primary source of data and then train our model through deep learning. But first and foremost, important thing is to understand the term speech recognition and how this amazing trait of human cognition was mimicked and what it helps us in achieving. You must have interacted with Alexa and Siri. How do you think it all works in real time? How can they understand your wish and then react accordingly? Especially since we all sound different and each command that we say may sound differently at every occurrence. Let us look at the formal definition of speech recognition. Speech recognition, also known as automatic speech recognition, that is ASR, is a computer speech recognition or speech to text is a capability which enables a program to process human speech into written format. While it's commonly confused with the voice recognition, speech recognition focuses on the translation of speech from a verbal format to a text one, whereas voice recognition just seeks to identify an individual user's voice. Speech to text. Of course, one of the major perks of natural language processing is the conversion of speech to text. The real time words that we speak, or as we speak, the NLP through deep learning can help us with the text to speech conversion of words that we utter. In short, the sounds we make into the words we read. That is the text block we get on a computer screen or maybe a piece of paper. Let us delve into another perspective. Think about this. The words that you utter are subjective in nature, but on an objective level are mere sounds. Special sounds that we make in a specific tone, voice, through our movement of lips and then tongue too. We have five senses and no sense mentions a word recognition facility. We can only hear sounds. So our primary sense that comes into play is hearing of course. Then this audio data is mined and made sense of this calling for a reaction. The NLP works almost on the same profile. There are models based on algorithms that get the audio data, which of course is gibberish to them in the beginning, and then try to identify patterns and then come up with a conclusion that is text. Preparing for NLP speech to text. We have already got enough of the idea of what natural language processing is and how does it work. Now let us look at the technical side of it as a process as if we wish to deploy. There are certain prerequisites to any such project, both basic and specific. Like programming in a specific language, which in our case will be Python 3, because it is one of the most reliable and productive languages given its utility and conveniences it offers to programmers. In machine learning and other processes like deep learning and natural language processing, Python offers a range of front-end solutions that helps a lot. As there is a huge range of libraries in Python that help programmers to write too little a code instead of other languages which needs lots of lines of codes with the same output. Hence, Python is preferred. However, on the other end, when it comes to the execution of the codes, Python is slower, but it is compensated as the coding saves a lot of time. The coding environment, converting natural language to the code. For Python, we can use the Jupyter project, which is an open source software that facilitates the Python environment and for anyone having the knack of programming and who wants to learn it conveniently. One more and my personal preference is Google Collaboratory because of its suggestive features while writing the codes. In Google Collaboratory, the most convenient of its features is its suggestion as a pop-up while we are writing codes to call a library or a specific function of any library. This is particularly why in the previous video lectures, when we were running codes on Google Collaboratory. Putting things into perspective. Keeping it simple, the main process of a speech to text system includes the following steps in order from 1 to 4. The first step is the uploading of audio file or the real-time voice from the microphone or a recording that's the audio data. Then second comes the process of converting the sound into electrical signals, that is feature engineering. In the third step, using analog to digital converter for conversion of signal into digital data, that is the input. Using the specific model to transcribe the audio data into text output will be the fourth step. We see that the speech to text using Python doesn't include many complications at all, and all one needs is the basic proficiency with the Python environment. Let us see how exactly all these four steps are deployed through a Python program. Speech to text converter in Python, kicking off with it. Now that we have seen all the prior resources ready on hand, it's time we try and put our skills to the test and see how things work. One most important thing while writing any program is the pseudocode. Simply put, a pseudocode is an English narration of every step or every action that we take while writing the codes. For example, if I am to call the pandas library, the code and the pseudocode will go something like this. Now we will call the pandas library to bring in the data and start cleaning it. This is a pseudocode. Important pandas as PD actual is the actual code that will be placed in the program into action. Now let us see what libraries we will need. In the first step, that is speech recognition, our task is to identify words and phrases in the input audio file and later convert them into text for human comprehension and reading. In case if the code doesn't work, we need to install the speech recognition package, for which we will use the code as conda install c -c conda forage speech recognition. We have the code right here. You can write this code down in your notebooks when you're working it out. This will come in handy. It is conda install space -c, then conda forage speech recognition. You can use this command and then proceed with step 1, that is the speech recognition from input audio file. Usually this takes some time, about 30 seconds to download, but it may vary depending upon your internet speed. The third step is using the recognizer class, which is a package of speech recognition for the recognition of speech and its conversion into text. There are several methods for reading a range of audio input sources, but we will for now use recognize Google API. The recognize Google API function has been highlighted for your reference. Thus, we must create an instance and an argument called audio data. Now, since we will be using the microphone as a source of speech, thus we need to install Pi audio modules through the command conda install e conda forage Pi audio. Now, if we look into the previous slide, for speech recognition, we had the command conda install -c conda forage speech recognition. And here we have conda install -c conda forage Pi audio, which means that the first elements will remain the same, that is from conda to forage will remain the same, and then followed by the packages or modules you want to install. Speech recognition was the module installed in the previous slide. Now we will be installing Pi audio module. We can check the available microphone options by calling the list microphones uh, m- li- by calling sorry by calling the list microphone names. That is this function right here. We then need to set up for the conversion of spoken words to test through Google Recognizer API, that is speech recognition APIs, by calling the recognize Google function, which we have right here, and further we will pass the audio data into it. Finally, putting the whole thing together, we can very, very, very conveniently get the things done. That is conversion of speech to text. The packages we need to install are speech recognition and PyAudio. The libraries to be installed are speech recognition and PyAudio. Notice, however, that the speech recognition library, speech recognition and PyAudio libraries are not the same as the packages of speech recognition and PyAudio. The functions to call are speech recognition and recognize Google. We have now gone through the way how you can convert speech to text. Feel free to explore upon this in your free time.